And welcome back to our final math class. Today we are going to look at differentiation of simple trigonometric functions. Okay, so we have the geometric function, which are the basic ones, which is the cos, sine, and then the tan, and then the simple one at all is the cos and then the sine. So we are going to look at how to differentiate the cos and sine. Okay, now the first thing that we will look at is how to differentiate sine. How to differentiate sine x. Okay, when you have sine x and you are differentiating, what you'll be obtaining will be cos x. Okay, so if you have an expression whereby you find sine x there, you end up what? Getting cos x. And the next one is if you have cos x and you are differentiating, what you will be obtaining will be minus sine x. Okay, so these are the basic things that you have to keep in your head. Now the third one is a little bit cumbersome as compared with this one. So if you have y to be equal to sine ax, okay, now when you differentiate this, the differential coefficient of sine ax will be equal to, you have this a. It is a function, all right, okay. A is a function or it's a constant, okay. So you differentiate that function. So you have it to be a cos ax, okay. You have it to be a cos ax, all right. And then the fourth one is if you have y to be equal to cos ax, okay, that one too, the differential coefficient or the y dx of that one too will be what? Minus a cos ax, okay. Since when you differentiate, minus a sine ax. Since if you differentiate cos, you'll be obtaining what? Minus sine. So that one a will come out and then minus sine ax, okay. Now in general, what you will be obtaining is, or what we know on this is, if you have y to be equal to sine of a function, say f of x, all right, then the differential coefficient of this sine of a certain function will be, first you will differentiate this function to obtain the derivative of this function, then you bring it out here, okay. So you'll be obtaining what? The derivative, which is the f prime, okay, or the dy dx of that particular function cos the function itself, okay. So when you compare this with, if you understand it very well and you compare that with the example that we just gave here, you realize that that's what we are talking about. Or when you compare it with this one, you realize that that's what. So you have a function which is y to the equal to sine ax. So the sine ax is the function which is what? F of x here. So what you do is to differentiate this. We know that when you differentiate ax, you will be obtaining what? A. All right, when you differentiate ax, we did it in the rules of differentiation, okay. So when you differentiate ax, you have a, then you bring it outside, then this sign, to differentiate the sign, you get cos, then the expression is which is the f of x will come. So here we have y equal to sine f of x, okay. So there you differentiate the f of x, then you bring the solution outside. The result that you will obtain by differentiating f of x, you bring it outside, then the sign will change to cos f of x. The same way if you have y equal to cos f of x, okay, first you differentiate the f of x, okay. So you have f prime of x, okay. So f of x is the same as the first derivative, okay, which is what? Dy dx. So then here will be what? Minus, okay. The minus will come, then the differential coefficient of the function, okay, then sine f of x again, okay, which is the same approach as the first one, okay. So we will take few examples to illustrate the explanation that we just gave on the board to further our understanding on the examples that we of the short explanation that we just did here, okay. Now we have the examples on the board, and the first example is if you have cos x plus sine x, how do we differentiate this, okay. So dy dx of this will be equal to, now we learned in the previous means that if you have cos x and you are differentiating cos x, you have what? Minus sine x, straightforward, okay? Plus, if you have sine x and you are differentiating, you just automatically get what? Cos x, okay? So rearranging this to make the expression look nice, you just interchange them, bring the cos. Since the cos is positive here, you bring it as what? Cos x minus sine x. So if you differentiate cos x plus sine x, you'll be obtaining the differential coefficient of it to be cos x minus sine x, okay? So quickly, let's look at the next example. So the next example is 4 minus cos 2x, okay? So now 4, when you differentiate cos 4, which is a constant, we know you have what? 0, which we learned in the rules, okay? So the rules are what we are applying here. So if you are new to the page and you haven't visited the video which we tackled the rules of differentiation, I entreat you to go back and then look at it very well to better or further your understanding, okay? Minus cos 2x. So as we learned in the previously, cos 2x, first of all, this is the function which is what? 2x. So we will differentiate this function, then we bring it outside, okay? And first of all, you have to know that when you differentiate cos, you have minus sign, so minus will come first, okay? And when you differentiate this, we have 2x. When differentiated, you get what? 2. All right, then the cos will change to what? Sine. Then you repeat the function again, which is what? 2x, okay? So by simplifying, our dy dx will be equal to 0. Minus will tend to what? Plus, okay? So plus, and to be what? 2 sine 2x, okay? So if you have this question, which is 4 minus cos 2x, this is what you'll be arriving at. And then the third question says that 2 cos 4x squared plus 2. What will be the derivative of this particular question? Now, what you do is dy dx will be equal to, now this is a constant, okay? So that one will come, all right? And then we know that when you differentiate cos, you have a negative sign, okay? So bring the negative first, then you bring this constant, then you differentiate this, then you bring it outside to multiply the constant, okay? So when you differentiate 4x squared, you have what? 8x, okay? So there will be what? Times 8x. Then when you differentiate cos 2, we know you have sine, all right? So the sine will change to what? The cos will change to sine. Then sine, then you repeat the function, which is what? 4x squared plus, this is a constant. When you differentiate a constant, you have what? 0, okay? So your dy dx will be equal to minus 2 times 8x times all of these. You have what? Minus 16x, then sine 4x squared plus 0 will just join, okay, because it is 0. And this will be the solution of the third question. And then now this is all the questions. So we've solved how many questions on this? 1, 2, 3, okay? So the first one is just this. When you differentiate cos, you have minus sine, okay? When you differentiate sine, you have what? Cos. So you rearrange it and have your final answer in this way. You can leave it like this, but to make the expression look nicer, that's why I came down to rewrite it in this way. Now the second question is 4 minus cos 2x. We know that when you differentiate a constant, you have 0, okay? And when you differentiate cos, we know you're obtaining a negative sign, okay? So you write the negative, you bring this minus first, then the negative will come. Then you differentiate the function of this, which is the f of x. Now when you differentiate it, you have 2, so that 2 will come out. Then the sign will change to what? The cos will change to sine, the times the 2x that is in the original question. Then you rewrite the expression, or you simplify it and have your answer in this way. Now the next thing is the third question says that we have 2 cos 4x squared plus 2. Okay, that one, to differentiate this, we know that when you differentiate cos, you have a negative sign, okay? So you bring the negative first, then this constant 2 will come, times 8x. 8x is when you differentiate the function in the question, which is what? 4x squared. When you differentiate, you have what? 8x, all right? Sine, the cos will change to sine. Then you repeat the function in the question, which is what? 4x squared plus, when you differentiate this constant, which is 2, you have what? 0. So now this is what the expression that, so you simplify the expression that you have here. Now when you simplify minus 2 times 8x, you have what? Minus 16x. So minus 16x, then sine x will come, then you repeat the function. And this will bring us to the end of today's lesson, which is differentiation of simple trigonometry function. Do have a nice day.